As we venture deeper into the mysteries of our solar system, the asteroid belt continues to raise profound questions. Is it truly just a graveyard of rocks that never became a planet? Or is it the last remnant of a once thriving world? An ancient planetary civilization, perhaps, now reduced to rubble and drifting silence. Let's revisit the four most massive bodies in the asteroid belt: Ceres, Vesta, Pallas, and Hygiea. These aren't just space debris. They are worlds in miniature, each one offering unique clues about our solar system's chaotic infancy. Ceres, as we learned earlier, is the crown jewel of the asteroid belt. At nearly 7 kilometers in diameter, it's large enough to be classified as a dwarf planet. What makes Ceres especially fascinating is the presence of bright spots on its surface. Detected by NASA's Dawn spacecraft, these spots are believed to be salt deposits, possibly left behind by briny water seeping from the interior. This hints at a radical possibility that Ceres once had, or may still have, a subsurface ocean. If confirmed, it could mean that even this distant icy rock has the conditions necessary for life. Not intelligent life, perhaps, but microbial ecosystems that may have persisted in the darkness for billions of years. Moving on to Vesta, we find a different kind of story. Vesta is much rockier, much brighter, and has a huge impact crater at its southern pole, Rhea Silvia, which is over 500 kilometers wide and 20 kilometers deep. That's nearly the size of the asteroid itself. This crater, and the debris blasted from it, are believed to have contributed to a class of meteorites known as Hygiea meteorites, some of which have been found right here on Earth. So, in a way, you could be holding a piece of Vesta in your hand without ever knowing it. Pallas, the third largest asteroid, has a highly tilted orbit, making it harder to reach with current spacecraft. Yet what little we do know suggests it's a primordial survivor, composed of material unchanged since the formation of the solar system. Studying Pallas could be like reading a chapter from the universe's own diary. And then there's Hygiea, a dark and mysterious body that barely qualifies as spherical. Hygiea might have formed not through accretion like the others, but as a result of a violent collision, reshaping itself from the fragments. If that's true, then it could be the cosmic twin of the disruption theory itself, a visual metaphor for what could have happened to Fyatin. Each of these bodies carries its own scars, its own narrative, carved by time, collisions, and solar winds. Yet they all orbit in the same space, the asteroid belt. But what keeps this region so distinct, so oddly balanced between chaos and order? The answer lies once again in Jupiter. With a mass 2.5 times that of all the other planets combined, Jupiter's gravitational influence is immense. As the solar system formed, its presence disrupted the orbits of nearby protoplanets, sending some careening into the sun, others ejected into deep space, and some shattered entirely. It's not hard to imagine that a forming planet, Fyatin, as it was once named, tried to hold itself together in this turbulent zone. But as Jupiter grew and flexed its gravitational muscles, the young world could have been torn apart, leaving behind the fragments we now call asteroids. This raises an eerie parallel to what's known as the Roche limit, the minimum distance at which a celestial body can orbit another without being torn apart by tidal forces. Cross that line, and the planet doesn't just crumble. It explodes into a disk of orbiting debris. So maybe Fyatin didn't just fail to form. Maybe it succeeded, only to be torn limb from limb by Jupiter's gravity, like some ancient cosmic sacrifice. But if this lost world truly existed, could it have hosted life? Some scientists speculate that if Fyatin had a stable orbit for a long enough period before its destruction, it could have been geologically active, with volcanic systems, magnetic fields, and even oceans. Under such conditions, primitive life could have evolved, only to be annihilated in a cataclysmic event. We may never know, but as technology advances, we're not just observing asteroids, we're visiting them. In recent years, missions like Japan's Hayabusa and NASA's OSIRIS-REx have actually landed on asteroids, collected samples, and returned them to Earth. These rocks are time capsules, preserving the chemistry of the early solar system. And soon, we may apply these same techniques to bodies in the asteroid belt itself. One day, we might even build space stations or colonies within the asteroid belt. With proper shielding and infrastructure, Ceres or Vesta could become stepping stones to the outer solar system, a place for mining, science, or even habitation. Think about it. A world that failed to become a planet might one day become home to explorers from Earth. The irony is poetic, and the future limitless. But before we rush into tomorrow, we still have ancient puzzles to solve. Some astronomers believe that among the asteroids lies something more. A massive, undiscovered object with enough gravity to explain anomalies in the Kuiper Belt. This hypothetical body is known as Planet 9. Could it be hiding at the edge of the solar system? Or is it a phantom conjured by gravitational math? Whatever the truth, one thing is certain. The more we learn about the asteroids, the more they reveal the skeleton of a solar system in its infancy. They are not just debris. They are witnesses, and they have stories to tell. In the next episode of Infinity Beyond, we'll explore the strangest kinds of asteroids ever discovered. Metallic monsters, tumbling twins, and ones that spin so fast they're on the verge of tearing themselves apart. Don't miss what's coming next, and if you haven't yet, subscribe to Infinity Beyond for weekly journeys through time, space, and the cosmic unknown.